Science communicators look like teachers, but they're not quite the same. So let's see how Physics Girl sets up her ethos for both of these roles. Hey there friends, last month we started talking about the rhetoric of science, or more specifically the rhetoric of science communicators or popularizers. And we talked about Jeannie Fonestock's argument that popularizers communicating with the public differ from scientists communicating with each other, and that their discourse is epideictic. That is, it's not about discovering and validating scientific knowledge, that's what research papers are for, but about motivating interest in science by showing people why science is amazing or useful. So we shouldn't fall into the trap of thinking that science communication is a cheapening of science for the little brains. It's really just doing a totally different thing for a totally different purpose. And it's easy to dismiss the self-flattery that's baked into the idea that science communicators are something less than research scientists. But there's a distinction that I think is actually even more interesting, and that's the difference between science communicators and science educators. Last time, we caught a glimpse of something that popularizers from across disciplines do fairly commonly. They begin by exporting their classroom habits to a public forum like YouTube, but eventually pivot to something different and consequently finding larger audiences. And to look into this, we could do a comparison of somebody's early work and their later work. But there's a really interesting example of a creator doing both teaching and popularizing in two different videos at nearly the same time and covering pretty similar conceptual ground. In 2020, Diana Cowan, aka Physics Girl, released two videos that made a focal point of her ballistic ping pong ball cannon. The earlier of the two, called Ballistic Ping Pong Ball versus Tennis Ball at 450 kilometers per hour, demonstrates the cannon at work and uses that cannon as a way into talking about acceleration and its relationship with mass and force. The later of the two is part of a playlist called Diana's Intro Physics class, and it's entitled 1D Motion and Kinematics, Physics 101/AP Physics 1 Review with Diana Cowan. And like it says on the label, it focuses on the basic mathematics of linear motion, especially velocity and acceleration, and it uses the ball cannon as an example of that math in action. And, I was thinking about the best way to present this analysis, but the fact is I've already written nearly 60 pages of analysis on these two videos, so I thought, why duplicate that work? I think we'd all get a kick out of me just reading it to you, so here goes. Chapter 2, Instruction versus Popularization, a case study of Physics Girl. This section and the analysis that follows aim first to outline the approach that I will take in analyzing the work of established popularizers, and second, to establish the difference between popularizing and pedagogical texts. This distinction is an important one to make for two reasons. The first is to establish a more exacting definition of popularization. Popularization is usually understood to involve the communication of specialist knowledge to non-specialist audiences, but such a definition leaves room.
Hello, what is it? Well, Mr. Whispers, I don't see why I should care that someone's ruining their show more than normal. What's that got to do with me? Oh, so you say you're calling to report an unauthorized rhetorical situation investigator, and that you're calling me because I'm the only RSI you've got a number for, huh? Well, I'll have you know you're ruining my afternoon, but given our history, I'm sure they'd send me in to do the job anyway. Send me the case notes and I'll see what I can do.
All right, well, if you're investigating a rhetorical situation, it's probably no surprise that you're going to need to know a thing or two about rhetorical situations. So here's the skinny. Any situation is the context that you're in. A rhetorical situation is a rhetorical context. If we're going by the book, you've got some kind of problem or need that arises that can be solved or addressed in some way through talking about it, through rhetoric. And in that situation, you've got a person doing the talking, the thing they say, and the people they're talking to. In simple terms, the one doing the talking is going to try to say something in order to get the people listening what they need, or to show them that what the speaker wants is also what they want. But this is where real RSI work comes into play. See, if you're the one doing the talking, you got to figure out what's going on in the situation, and you got to understand what makes your audience tick if you're ever going to have a chance of responding to that problem or exigence in a fitting way. The real good stuff, though, is in looking back at how someone addressed their situation and then reverse engineering the whole thing. In most cases, you see, we don't get access to the speakers or the audience, and they often don't have direct access to each other either. So, if you know what you're looking for, you can find all kinds of clues about a rhetorical situation inside whatever the speaker created. You may not be able to go back and interview the audience, but you can learn a lot about who the speaker thought they were based on the way they're being addressed. And you may not be able to run a background check on the speaker, but you can learn a lot about them through the way they present themselves. It's like how Edwin Black put it back in the 70s. Discourses are, directly or in a transmuted form, the external signs of internal states. In short, we accept it as true that a discourse implies an author, and we mean by that more than the tautology that an act entails an agent. We mean, more specifically, that certain features of a linguistic act can entail certain characteristics of the language user. So all the clues we need are in the discourse. Look at how someone uses language and you can figure out who they are, or at least who they are in that particular situation. And it's not just speakers either. Black goes on to say, it seems a useful methodological assumption to hold that rhetorical discourses, either singly or cumulatively in a persuasive movement, will imply an auditor. The best evidence in the discourse for this implication will be the substantive claims that are made, but the most likely evidence available will be in the form of stylistic tokens. So we're not just looking at what the speaker is saying to learn about them and their audience. We're going to look at how they say it, the style that they address the situation with. Look at how someone does something, and you can learn a lot about who they are and who they think their audience is. And that's the basics. Looking at this case file, we're supposed to be talking about how all this works in a couple of physics videos, I guess. I was hoping to spend the day watching people come and go under fog-muffled streetlights, but I guess I'll be earning this one today. So let's start with our perp, Diana Cowan. The report says she graduated from MIT with a degree in physics and then went on to do research at the Harvard-Smithsonian Center for Astrophysics before spending some time working as a software engineer at GE, where she started making physics videos. This kind of stuff is useful to a point, but it doesn't tell us much about her rhetorical strategies as a teacher or a science communicator. For that, we're going to have to look at the discourse. So what do you say we get warmed up with just the titles and thumbnails of these two videos in the file? We'll start with 1D Motion and Kinematics Physics 101/AP Physics 1 Review with Diana Cowan, and try to get a bead on who she expects her audience to be, and what's motivating them to click this video. What do you notice? The title, by itself, tells us a lot about the exigence or need in this situation. We're dealing with an audience of students in introductory physics classes, either Physics 101 or AP Physics 1. And what do they need? Help learning about 1D motion and kinematics. So Diana's created a video title that not only makes it very clear to her audience that she's trying to meet their need, maybe something like having an exam soon and wanting some extra review, but it also shows sensitivity to how she expects her audience to encounter this video. And this is the reconstructive work our investigation is all about. So imagine it. You're in a mid-grade panic the night before your kinematics test, so you go to YouTube and what do you type in? Maybe kinematics and AP Physics. And would you look at that, a video with a title that is both transparently advertising an answer to your problem and is likely to show up in a search with those keywords. So our implied audience is students in these classes looking for help with these topics. And of course, the thumbnail plays some backup there too. But there's lots of videos that talk about kinematics, so what's motivating someone to click on this one? Well, I think this is where we see the role of the implied speaker becoming a little more important. There are plenty of videos that talk about 1D motion and kinematics, so we're not getting unique content here. So why watch this video if you could just have an almost reliable chatbot teach you this stuff? Well, we add a little more to our understanding of the whole situation, the audience, and Diana's approach by the fact that her name is in the title and her face is in the thumbnail. If the title and the thumbnail are meant to motivate people to choose this video over all the other videos, why might someone pick this one? Well, it looks like she's banking on her established persona as a YouTube science person to do at least some of the heavy lifting here. Maybe a viewer who already knows her content, but is now in a class, is motivated to get their review material from a familiar face. But even people who don't know who she is could still connect the dots and see that who she is clearly matters. It's a demonstration of authority on the topic that's also tempered by the smiling face and bike helmet. This is a person who knows her stuff, but by the looks of it, she's not going to be boring about it. So let's take a step back and fill in the investigation report so far. What do we know about the case? The direct references to school classes make it pretty clear that we're dealing with a teaching scenario. We likely have students who have to know something for school, probably a quiz or a test, and they probably come to YouTube looking for answers. But not just answers. They could get just the answers from anywhere. But this title and thumbnail combo promises something a little more human, a little more engaging and personable than just a rehearsal of what these students need to know. For the real people who identify with this implied auditor profile, this is an appeal that could get clicks. And that's not what's going on in the other one. Let's take a look. We'll do this one a little more quickly, but notice how it clearly implies a different rhetorical situation. We don't mention classes, and we don't have the explicit technical references to things like kinematics. So how do you think someone is going to encounter this video? What's the need or exigence motivating them? Well, it seems pretty safe to say that there wouldn't be many people opening a new tab and specifically searching for ballistic ping pong balls smashing into tennis balls at 450 kilometers per hour. At least, nobody you should trust. No, this title and thumbnail combination doesn't seem designed to capture someone's search terms. And it's not really making any promises to address someone's urgent need like preparing for a test. In fact, the question posed by the thumbnail gets answered in the title, so not even that's going to be pulling in a click. Instead, this one seems pretty clearly to address an audience of scrollers. These are not people specifically searching for information about 1D motion and kinematics. This is a suggested video. It's one that a potential viewer happens upon rather than seeks out. Someone sees the question, witnesses the before and after, and then experiences all the ballistic sense of awe that comes with a 450 kilometer per hour ping pong ball, and then they decide they want to see more. So on one side, we have someone who needs to learn something about kinematics and is searching for a video that will teach them what they need to know. They're motivated by a largely extrinsic need, a class or a test or something like that. And then on the other, we've got someone whose interest is piqued by the dramatic image and high-speed title. They're motivated by a largely intrinsic need, probably to satisfy their own curiosity. These aren't the same audiences, and these situations don't arise in response to the same exigences. So, of course, our speaker can't respond to them in the same way, which she doesn't. But before we get to that, maybe we should check in on our boy. But the larger point remains. While popularizers and pedagogues are both engaged in communicating specialist knowledge to non-specialist audiences, they are engaged in markedly different activities. To include pedagogical discourse in a study of popularization, then, would... Alright, so we've got two situations where Physics Girl has knowledge that she's sharing with her audience. But like we've determined from the evidence in each text, she's sharing knowledge with different audiences and they have different reasons for seeking that knowledge. So, clever communicator that she is, she makes sure to address those audiences in different ways. And we could probably get away without saying it, but just to be safe, both of these videos are Physics Girl videos. Physics Girl cannot help but be the Physics Girl in both. So saying that there's a difference in her implied persona in each is not to say that she's a different person or that she conveys herself to be a totally different individual, just that we see different aspects of her persona in each. Maybe something like the distinction Andrew Inkpin sees in the philosophy of Maurice Merleau-Ponty between personal style, which correlates to an embodied agent's overall way of being, and artistic style, which is reflected in features characterizing works themselves. That is, Physics Girl is, of course, Physics Girl, but the way she presents herself in each differs in response to the situation she's addressing. But we could talk theory all day if I were getting paid by the hour. Since I'm not, though, let's just get into the stuff. So, 1D motion and kinematics. What do we get? Well, something that looks like this. Run the tape, Whispers.
So the slope of this line is our change in position over our change in time, which equals velocity. I look at this graph and I can tell how fast she's going by looking at the angle of this line. Let's check that with units. Here's another aside. Throughout this course, we're going to pay close attention to units. My high school teacher taught me this trick, and it's called dimensional analysis, and it helped me solve so many problems during my college exams at MIT. I kid you not. We are not going to write down an equation in this course without checking the units to see if they make sense. Physicists use dimensional analysis all the time to make sure that we're not adding apples to oranges or pie to cake. Sounds really good though. So let's think about our units here. Delta x, which will be meters, and time, which will be seconds, equals, and the units of velocity are meters per second because it's a rate of distance. Checks out. Did you guys know about this? Dimensional analysis? Did you do that in like your high school class? It's so useful, I swear. Now, the graph we drew is a model of her motion, but the algebraic form of the graph is also a model of her motion, and it's a powerful one because you can manipulate algebra. Check it out. Looking at the slope of this graph, I've defined it as delta x over delta t and called that velocity. If I multiply both sides by delta t, these cancel. Oops, just kidding, that doesn't cancel. I have a new equation. Delta x equals v times delta t. Just by doing that simple trick, we can calculate her change in position. We have a new tool. This is a new tool.
So there you have it, folks. A little demonstration of velocity algebra and the importance of keeping track of units. But what can we observe about Diana's teaching persona? Let's just start with where she is. Clearly, this is some kind of set. We've got outer space in the background, shelves with sciencey things, a whole bunch of physics alphabet floating up in the air, with clouds and mechanical gear and other stuff. If you're one of our answer-seeking viewers, what does this communicate to you about the creator you're spending time with? Unambiguously, that this is a science person. If you've got equations floating above your head and metal circles on your shelves, you've got to know what you're talking about. But it's also playful and aesthetically minded in a way that sets it apart. We could have filmed this in some distinguished professor's office with outdated books choking the shelves and overstuffed folders spilling their ratty contents on the desk. That would also probably show us that we're dealing with someone who knows their stuff. But again, our viewer doesn't just want answers. If they're getting past the promise made by the title and thumbnail, they also want the answers from someone a little more personable. So it's colorful, lit in interesting ways. There's even literal fluff hanging from the rafters. So, for all you science elitists who will no doubt be tempted to show up in the comments, here's confirmation of your preconception. It's a literal puff piece. Except, of course, it isn't. The clouds don't serve a scientific purpose, but they do play a role in the overall rhetorical purpose of the set design. They position Diana as a scientific authority, but not a stiff and humorless one. And we can see other moments of humor, personality, and even making and correcting errors, all of which work to humanize the way she goes about presenting the content. But we're here to do a job, and even though we get to see her drop markers and draw unfortunate bicycles, our focus is always on the physics and the mathematical models. Then the instruction plays out on the blue paper. It's reminiscent of the way a teacher might work a blackboard, but instead of watching her at the front of the room from a seat in the back, the camera puts us over her shoulder, creating a certain sense of closeness. So we're not really dealing with an instructor spouting physics from behind a lectern. Really, we might characterize her persona as a knowledgeable and friendly tutor, or TA. We're working together on paper at the same table, not receiving a lecture from opposite ends of a classroom. We end up then with a speaker persona that makes an effort to be personable, but also is still decidedly authoritative. Cowan has the answers and the knowledge, and even the MIT credentials to boot. The audience needs what she has, and playful though she may be about it, she shows up to present the knowledge that she has. Really, it's a classic case of what Alan G. Gross calls the deficit model of science communication, where there's a one-way flow from science to its publics. The public is made up of passive receivers of information, and the central focus is on the science. But we see something pretty different in the ballistic ping pong video. Let's take a look at what I'd like to call Exhibit B. Whispers, that's you. Yeah, what are you going to do about it? Whisper in my ear? Listen, you're the one that called me in, so you're just going to have to do what I ask.
I think we all have a sense that driving a bigger car is safer, but is it as simple as bigger is safer? My mom seems to think so. This is her approximate height as compared to Shaq, so she's tiny. And this is the size of the car that she drives, for safety, she says. But if she were driving a Fiat, here's my Fiat, this chocolate chip represents her energy if she's driving at 80 kilometers per hour. If a semi were going at 80 kilometers per hour, this would be its energy. So yeah, the truck has a lot more energy. I'm gonna take my mama out of the car for this next hypothetical situation. Okay, imagine a driverless Fiat and a driverless semi are going towards each other at 80 kilometers per hour each, and they crash head on. The crash wouldn't look like this. It would look more like this. The Fiat would be pushed backwards up to a velocity of 76 kilometers per hour, because though all of this kinetic energy isn't all conserved, some of it gets gobbled up by heat and friction and deformation of materials and so forth. But momentum is conserved, and there's a whole lot more of it going in this direction at the beginning of the crash. Yo, That's insane. Because you know what that means? The semi was initially going forward at 80 kilometers per hour, and it can end up going backwards at 76 kilometers per hour, which in total is a speed change of 156 kilometers an hour, which is like hitting a wall going 156 kilometers per hour, which is why the casualty rate per million 1 to 3-year-old minis, another small car, in 2007 was 3 times that of large cars. People have looked into banning large cars from city centers because of this physics, and also because traffic congestion sucks.
Well, what do we have here? Where do we meet the physics girl this time, but in what appears to be her living room? Instead of watching a presentation from a soundstage, we're sitting on the floor across the coffee table from not a science teacher, but a science communicator. And we can see that she's constructing her authority in a different way. Remember, we're not here now because we have to be. We're here because we clicked on the video about the ballistic ping pong ball. We're not studying for a test about kinematics equations. We're enjoying some recreational science in our spare time. So the setup positions us differently. Where Cowan was a teacher or tutor in the previous video, she's now welcoming us into her living space, hanging out on the floor and talking about mass, acceleration, and force, kind of the way two friends might. And you might catch the references to your favorite Star Wars or your favorite math popularizer along the way. In other segments, we're still presumably at her house, but we get to see the books on her shelf, her keyboard, the musical kind, and even a clock that gives us some insight into the filming process, all mixed in with the physics and math. And that would be Exhibit C, little one.
And this is at 18,000 frames per second, so we can use some creativity to figure out how fast the ball is going by knowing, Googling, that a standard soda can is 6.6 centimeters in diameter. That's our ruler. Then the ball goes about 0.7 centimeters in one frame, which at 18,000 FPS works out to 0.0000555555 seconds per frame, which all converts to a speed of 12,600 centimeters per second, or about 450 kilometers per hour. That's fast, which is fast enough to make an aluminum soda can keel over in pain. But soda cans are not all that strong. In fact, it's a trick you can do to rip one in half with your bare hands. Tear one in half with their bare hands. In fact, some people can even tear one in half with your bare hands. Oh! But what about when you shoot a tennis ball?
In terms of content, you can see we're talking through calculations of the ping pong ball's speed based on frame rates. We're using bananas and chocolate chips to illustrate the relationships between force, mass, and acceleration. We're getting some basic understanding of scientific concepts and ways of thinking, but we're not getting the charts and equations we got before. And that's because the goal isn't to teach people how to solve kinematics problems for a test. The goal now is to show people where physics connects with everyday things like automobile safety and how it applies to crunching up soda cans with ballistic ping pong balls. It all brings us back to the idea that popularizers are working to show us why science is useful and/or awe-inspiring. But that's not real physics, some people might complain. But does it need to be? This video isn't trying to train physicists. It's giving people a place to start, showing them why physics is relevant to them. If some of those viewers go on to become physicists, well, great, that's what PhD programs are for. If most of them don't, though, why would anyone complain about more people appreciating physics and having a more positive view of it? It would be like having a meltdown over someone saying you could just enjoy poetry without having to do academic close readings and analyses of it. The fullest, most academic expression of a discipline is not the only way to participate in it. Popularizers are opening the door, expanding the reach of disciplines beyond tiny academic conferences. Because of that, communicating knowledge is important, like it is with teaching, but it is not the only priority. It's like Greg Myers says, popularization is a matter of interaction as well as information. It involves persons and identities as well as messages. So the message matters, of course, but the personality matters a whole lot too. So this second video foregrounds personality in a way that the first one just doesn't. We've already talked about the setting and the personal insight we get from books on shelves and things on couches. Rather than a curated set that tells us this is a science person, we get a living space that tells us this is a person with a copy of The Food Lab and Catch-22 on our bookshelf. These clues tell us something about personality in a way that the previous video's set design just doesn't. And then we get little comments on the screen, poking fun at the chocolate on her forehead or her gleeful squeals. But why put text on the screen in a video about acceleration? Science is important, and that's just distracting. Why would you want to distract a viewer with extra words on the screen while Diana is talking about physics? Because the information is only half of the game. For a popularizer, the other major battle is personality. So a minor distraction from the content for the sake of highlighting a personality, that's a more than affordable loss, if it could even be counted as a loss at all. And what do we think about a person who is willing to do some self-deprecation while talking about physics? Of course, personality matters in teaching. Anyone who's read student evaluations could tell you that. But it's doubly important in popularization. And you don't need an RSI to tell you that on a platform like YouTube, personality is an essential selling point. So you could be an expert know-it-all with no distractions and high-level academic theoretical physics knowledge. Or you could invite viewers to sit on the floor with you while you poke some gentle fun at yourself and explain the basic physics of car crashes and show off a cool contraption you built, all with a couple of memes sprinkled in for good measure. And if your audience is regular people with curious minds, it might not be that hard to decide who they'd rather be spending their time with. Like Myers goes on to say, in any case, regardless of which scientific authority is at issue, the interaction between popularizers and the public is not a simple matter of the public examining the credentials of the expert to see if he or she is qualified to speak on a topic. It involves the active construction of believable or discreditable identities. And for a non-specialist audience, the kind of person you present yourself to be will matter at least as much as the quality of the knowledge you present. So really, those extra things aren't distractions at all. They're fundamental components of the rhetorical necessity of supporting the science with a compelling personality. And in this case, as in many others, it's a personality that's crafted to de-emphasize the popularizer's credentials, flattening the relationship between popularizer and audience, and transforming the dynamic from one of tutor and struggling student to one of two friends taking a break to talk about physics. And as the last couple of notes in the case file, I'll just add that, of course, this is one way to do this. Everyone will have a different personality and accomplish this task in a slightly different way, but the fundamental priorities will remain consistent. Also, I'll just add one last time that it's not just diluting science with spectacle and flash. The ping pong ball cannon video was made as a collaboration, and the other half of that collaboration really is just about using the cannon to destroy things. And, well, we can see that of these three videos, the one with the biggest audience response is the one that combines science and personality rather than emphasizing just one or the other. So, it turns out that people are interested in the physics. They're just also interested in getting it from an engaging human being. But I've been at this for too long. I say we call this one a case closed, and you can all go back to the read aloud. I'm going to walk through the rain to the diner at the end of the block to eat a grimy dinner by myself while I watch all those innocent people pass into and out of each other's lives, blissfully unaware of the rhetorical situations going on all around them in this miserable city. Where popularization is closely tied to the quality of the creator's implied self, it is reasonable to expect the range of popularizing personas to be at least as wide as the range of popularizers. Even more so when considering the possibility that a single creator can adopt different stances in different situations. So, with a fundamental understanding of the nature of popularization as a relationship-driven discourse concerning specialist knowledge and involving non-specialist audiences, it is important to understand the range of possible relationships available to popularizers. In the next chapter, we will take a look at that range of popularizing possibilities. So there you have it. At its most basic, we could say that the ways Physics Girl crafts her persona in each video is really a lesson in establishing ethos. Often we talk about ethos as a measure of a person's credibility, and that usually just reduces to whether or not they have the right degrees. But the word ethos refers to a person's character or disposition. So whether a person is seen as credible is not just a calculation based on their credentials, but on their larger personality as conveyed through a text. Of course, ethos plays a role in any rhetorical interaction, but we see from Physics Girl that how you shape and present your persona can and should change depending on your purpose. And teaching physics is not quite the same as popularizing physics. But why am I saying this? You know that. I mean, we've just read through it all together. Oh, that's the nicest thing you've ever said to me. Well, I suppose we all had such a nice time that we should probably just sign off here and end on a high. Thanks for joining me today, and we'll meet again real soon.